Okay, this is geometry lesson 4, part 2. Arnold has designed a Pratt. It's a style of truss bridge. You've probably seen these before. There's one in Edmonton, as shown in the diagram below. Okay, so what this is showing is from here up to here is 11.3 feet, and then it says it's 8 feet tall. It's okay, so from there to there, that is 8. The question is how long? So all the way along. Now these double lines mean each section is the same length. So if we could find what from this section using the numbers that we have, then we should be able to multiply by 1, 2, 3, 4, 5, 6 and get the total length. Okay, since we don't have any angles, we don't have any other choice but to use Pythagorean theorem. This is our hypotenuse. And with the style of equation that I've given you, you don't have to know if x is a or b, right? Or if a is a or b, they're both just s's, sides. So for this, side equals the hypotenuse minus side squared, square root. And you just have to know that the one that you are given, 8, goes here. That's all you have to know. So I'm going to replace s with x. Hypotenuse is 11.3 squared minus 8 squared. Okay, so I'll go 11.3 squared minus 8 squared, get the answer, and then don't forget to square root it. And I'm going to take 5 decimal places because we're going to be multiplying by 6. So 7.98060 feet. Okay, that seems pretty reasonable based on our other measurements. Remember, if you didn't square root, you would have got a huge amount of feet. It wouldn't have made any sense. Step 2, the total length. That's the symbol for length. Or you could use an uppercase L. 6 times x, 7.98060 feet. And we end up with, rounded to 1 decimal place, 47.9 feet. Okay. Now it says, calculate the interior, so that means inside, angles of triangle ABC. So that's right here, A to B over to C, so that giant triangle there. Okay. Now, looking at this, if you were to spin your sheet, that's a right angle. Okay. We also have equal side lengths. So for us, the first part, I'll just make this a little smaller so we can see it at the same time. Angle A, so angle A is a 90. We know that. Now, if you have two side lengths that are the same, that means this angle and this angle are also the same, equivalent. So because it is isosceles, and if you ever have to reference the triangles, they're back in lesson. There's a table of all the different ones. I believe it is lesson 3, part 1. Just got to look back at those tables that label the triangles by angle and side lengths. So because it is isosceles, angle B equals angle C. So what that means is if all of these angles add up to 180, we should be able to subtract 90 from 180 and then split the remaining angle into two, and we should get angle B and C. So we'll go 180 minus 90 gets us 90 degrees. Now, take that 90, because that 90 degrees has to be split between angle C and B. And if they're the same, then we just divide by 2. So we end up with 45. So angle B and angle C equal 45 degrees. Okay. Now I'm going to keep it on this page when we answer C, because you have to be able to look at the triangles. So classify triangle ABC. Okay, ABC by angle measure and side length. So this by angle is a right angle triangle, and two of the sides are equal length. So that is isosceles. So remember, if three of the sides are the same length, equilateral. If two of the sides are the same length, isosceles. If all three of the sides are different, scalene. Okay, so we can answer that one. So triangle ABC is a right angle triangle, and it is isosceles. And then triangle A, B, and D. Okay, so I'm just going to scroll back. A, B, D. Okay, A, B, D, right here. So from A to B to D, so half of the triangle here. Okay, so ABD by angle. Okay, so this would be a 45 because it's split in half now. We don't know, oh, we do know what that one is. That is a 45 as well. If it lies perpendicular to a completely horizontal line, you know that's a 90-degree angle. So this ABD is also a right angle triangle, and the sides are not the same. Okay, so this would not be the same as this one here. This would be 8, and we figured out each chunk was 7.98. So pretty close, but not the same. And then this one would be different. So this is scalene. So triangle ABD would be a right angle triangle, and scalene. Okay, number 8. So this one's going to take a bit of work here. Annie is building a door, and she will be installing a square screen. You can see it right here in the bottom half of the door. So that would mean that these two squares are equal chunks. She plans to add diagonal cross bracing from this corner all the way up to the other corner. So from here to here, and then one going the other way. The door is 36 inches wide. So from each edge. And the screen has a 2-inch border around it. You can see it here. So this is 2 inches across and it goes all the way around. The total height of the door is 7 feet. What is the length of the cross bracing? So each part of the X here, how long is it? Okay, so just looking at this, there is a number of ways we could do this. And I would think the best way would be to figure out the length of this, the length of this piece, and then find the hypotenuse of the triangle, which would be the cross member. Okay, so we got to find these two lengths here. Now they aren't 36, right? There's 2-inch spacing on each end, which would mean that the bottom would be 36 inches minus 2 on the left-hand side, and then minus 2 on the right-hand side to get the red piece here. So that would mean that comes out to 32. So this is 32 inches across. Now going up 7 feet, we have to turn that into inches. So 1 foot is equal to 12 inches. Also, you can tell by the ticks. So if you have a double tick like this, that's inch. If you have a single, that's foot. So therefore, 7 feet would be 12 times 7, which is 84 inches. Okay, so the whole thing is 84. Now, if we split it halfway, we should be able to get from here to here, which would be 30. No, sorry, it'd be 42. Okay, so that's 42 inches. Now, you have the 2-inch gap up at the top or spacing, and you have 2 inches at the bottom. So if we take 42 and we subtract 2 and 2, we're going to end up with 38. Now, you could just go subtract 4, okay? But I just like to show it all in case people are looking back and can't remember how we got the 4. Okay, so now our height here is 38. Now this is a right angle triangle, so we should be able to get the hypotenuse. Okay, so hypotenuse equals one of the sides squared plus the other side. It doesn't matter which is which. You can put the 38 first or the 32. It doesn't matter. It's addition. And that's why I kind of prefer just using hypotenuse and side. So you don't have to think about what's A and B and C. Okay, so 38 squared, 32 squared, square root. Okay, so 38 squared plus 32 squared is 2,468 under the square root. And we end up with 49.7 inches. Now, that's the correct answer, and I would mark that right. But if you, like, we know that inches is measured in sixteenths and halves and eighths and quarters, right? So 0.7 really doesn't do anybody any good. If you want to figure out what the sixteenths are, or the halves or the eighths, you just take the decimal part, so that 0.7, and you multiply it by 16, because it's 0.7 of the full 16 marks, so 70% of the way. So if I go 0.7 times 16, I'm going to get 11.2, which means that this length, and we're just going to ignore the 0.2, but it's 49 and 11 sixteenths. Okay, I don't need you to go that far, but that's how you would get that part. Okay. Number 9. We're going to have to look at it and remove some of the pieces and make them two-dimensional. So you got a large rectangular crane truss that is 4.5 meters long, 2.4 meters wide, 2.1 meters tall. The truss has a brace that runs from the corner across and down. How long is that brace? Okay, so this one is going to take some thinking. So if our ultimate goal is to find the length of this one, if you could somehow imagine this as a triangle standing up, okay, and that triangle would be a right angle triangle. Like if you could view it from the side, we would have, so I'm just going to remove it. There's the piece going down. Okay. So this is the top and this is the bottom of the box. The box is 2.1. This is the length of the truss piece. And then we need to know from corner to corner. So we don't know this piece. Okay. But if we did, then we could use Pythagorean theorem to find length because we'd have the two sides. So what we need to do is find this piece X first. Now, if you do a top-down view, this is also a right angle triangle. Okay. So this is lying flat. Okay. We know this is 4.5. That's this piece here. And then we know this piece is 2.4. So we should be able to find X. Okay. So number 1, hypotenuse equals 1 of the sides squared plus 1 of the sides squared, square rooted. And then I'll just replace hypotenuse with X. So 2.4 squared plus 4.5 squared and square root. Okay, 2.4 squared plus 4.5 squared is 26.01. That doesn't sound right because we still have to square root it. And we end up with 5.1. So X equals 5.1 meters. Okay, so now we know how far across corner to corner it is. So now we can take that and go up here. And now this is 5.1. And then we can do it one more time to find the cross member piece. So length, so that's hypotenuse again. 1 of the sides squared, doesn't matter which one you pick, plus the other one, square root. 2.1 5.1 and square root it. Okay, and I'm going to replace hypotenuse with the length symbol. $30.42 under a square root. And then length equals, and to one decimal place, 5.5 meters. And there's our answer. All right. That is the end of lesson 4, part 2. And now you have your assignment 5.1.